Hello, good morning, class. I just wanted to briefly talk about this article called What Eyes Can See. We discussed this information over the last week, but I just wanted to talk about it personally and give you a lecture. So, all you have to do for today is sit back, relax, enjoy the video, and later focus on the questions that I will be giving to you in the lesson directions. Okay, without further ado, let's proceed. So I'm going to talk about what's happening here. In this image, colors of light are being absorbed. Some electromagnetic spectrum, which we talked about, is being transmitted. But what is the electromagnetic spectrum? A lot of you might have had this question. I'm going to go over here. This is a little stimulation that we're going to see different types of light, with different frequencies. If you see all wavelengths of light or electromagnetic spectrum can produce energy. So what makes them different? If we look at this diagram right here, you're going to see gamma rays. Gamma rays is the most strongest type of electromagnetic radiation. And this you're going to see right here in between these two little peaks is this number. This number is extremely small. It's in meters, but we would use nanometers because it would break down that number into smaller terms to help us understand. And the frequency of this is extremely high. Gamma rays have a lot of energy. However, if you go and we start to go to X-rays, X-rays are slightly longer. Their wavelength meter is a little longer and they're not as distant. They're not as close together as gamma rays as you see. So this number is bigger and this number is smaller. Okay? And you can also see the frequency is lower too. The frequency over here is extremely high. So intensity is also high. These X-rays or electromagnetic radiation, these can damage your DNA and your skin. So that's why all the time you want to go outside with, protection, sunblock protection, because some X-rays and some radiation from the sun can pass through the Earth's atmosphere. Okay, let's keep on looking. How about ultraviolet rays? This is exactly what I'm talking when we look at sunblock. It has UV protection, UVA, UVB protection. We need sunblock because of these this electromagnetic radiation that is emitted by the sun. So this one as well is intensity is high. The frequency is also high. As we move on, we're going to notice that the wavelength, the distance between the peaks, will further, meaning that the wavelength is going slower and slower. As you get closer, it is an indication that the energy is increasing. Okay? So let's move on to violet. And pay attention to the words right here. You can see they compare the size. So between this is similar to a virus. This right here is similar in size of an atomic nucleus. That's gamma rays right here. So you can see the comparison in size if you want to know what is the distance or how big this distance is. Okay. So we talked about UV radiation and that's why we need sunblock. But now we're going to go into color. This is something that we can see. Violet is intense. The color is intense. However, we can start seeing these colors now, this visible light. This is what we call visible light. And as we keep on going, we will see that as the colors change, they will be getting longer and longer and longer, meaning that they will have less energy and less damaging. I only got 20 seconds left in the video, but I just want to show you the different wavelength. Right now we're looking at microwaves and radio waves, the longest and less damaging one. Radio waves are similar to the size of a bridge. Wow, I did not know that. And this microwaves